Hello, everyone. How are you guys doing today? Good. Did you submit your homework yet? Especially 1.2. If you haven't, if you have time till tonight midnight, please submit before that. And we are going to do some examples of Gauss elimination or Gauss-Jordan elimination. Okay? Any question before we start? Any comments, concern, complaint, anything? Nothing?
I have a question. Will you ever be posting the actual slides to Brightspace, or is it just me?
I will.
You will?
Yeah. I wanted to do it sooner, but I didn't have time to modify the lecture yet. So I'm using my old lectures and I'm modifying night before the lecture. So I'm planning to do them over the break. We have 3 days break after next week. So we have 5 days, including the weekend. So I'll have plenty of time to modify my lectures. So I'm planning to post them after the break. Any other question? Okay, so in our last class, we discussed how do you convert the augmented matrix into row echelon form, and if possible, reduced row echelon form. And we did one example, which is already done for us, but we are going to do the real or actual work today with 3 examples. That's my plan for today. And if you have time, then we are going to go to the next section, which is 1.3. But this takes a little bit time, especially since you're going to do it for the first time. It may take longer than what do you expect. So here we have 3 linear equations in terms of 3 variables. So we are going to reduce our augmented matrix. But before we do that, first we need to make the augmented matrix or write down the augmented matrix. Okay, any volunteer to tell me the matrix you're looking for here? Brendan. 3, 2, -1, 4, 1. Perfect. And you can separate them with a vertical line. So our goal is to convert this matrix into this form: 1, 0, 0, 0, 1, 0, 0, 0, 1, and then there will be some number on the right. This is our goal. Okay, rewrite this in terms of in this form. That means we want 1 here instead of 3. We want 0, 0 here. So when we reduce our augmented matrix, we should go column-wise, then it will be easier. So if you want to make this 3 into 1, there are 2 choices. You can simply divide by 3, or you can swap these 2 rows. If you divide by 3, we'll have a problem because these are not divisible by 3, so you have to work with fraction. If you don't like fraction, maybe you shouldn't use calculator because calculator will give you decimal, and then if you round in the middle, at the end you're going to get wrong answers. So you really have to work with fraction, not decimal. So instead of working with fraction, to make our life easier, you can simply swap these 2 rows. So step 1, let me change my color to red, is swapping them. Swap row 1 with row 2. So
What is this process called?
we are doing reduced row echelon form using Gauss-Jordan elimination, if possible. So we are switching row 1 with row 2. This is the operation here. Swap them. So we get the new matrix. 1, negative 1, 1, negative 2, 2, 1, 3, 2, negative 1, 4, 11, 2, 1, 14. So we have this, and you're satisfied. The next thing we want to do is erase the 3 and make it to 0. So any suggestion, how can I make 3 into 0? Let me do the first step for you, no problem. So we are going to switch row 2. So the new row, many people use, different people use different notation. Some people use new row 2 as the row 2 star. It means this is going to be new row 2. Or some people simply use F2 as row 2. So I like to use star so that I can see this is a new one, not the old one. So I'm going to change my 3 into 0. So that means I have to modify the entire row 2. So the new row 2 will be, I'm going to take the old row 2, the current one, row 2, and I'm going to subtract 3 times the first row. So 3 times 1 is 3, and we subtract this one, we get 0. So you can easily get 0 here by multiplying this by negative 3. So row 2 minus 3 times row 1. So this is the operation we are going to use. 3 times row 1. We can also at the same time make this 11 into 0 by multiplying this by negative 11. And then, or multiplying this by 11 and then subtract from row 3. You can change 2 rows or 1 row at the same time, no problem. So a new row 3 will be the old row 3 means the current row 3, and you're going to subtract 11 times row 1. I'm still using row 1 to get rid of both row 2 and row 3. We are allowed to do so. So if you want to do the math mentally, you can do it. Or if you want to do the actual math, you can also do the actual math. Let me do the actual math on the side. So current row 2 is 3, 2, negative 1, 4. And when you multiply row 1 by negative 3 or by 3 and the subtraction, we get negative 3, positive 6, negative 6, and negative 3. Right? 1 times negative 3 is negative 3. Negative 2 times negative 3 is positive 6. 2 times negative 3 is negative 6. 1 times negative 3 is negative 3. When you subtract, you change the sign. So I'm doing the changing sign and subtraction at the same time. So then it will be easier for me to just get the number when we add them. So we have 8, negative 7, and 1. This will be the new row 2. Yes. So let me write down my row 1 again. 1, negative 2, 2, 1. We didn't change row 1, so we keep our first row. The new row 2 is 0, 8, negative 7, 1. And then let's calculate the other one also. Let me change the color. Current row 3 is 11, 2, 1, 14. If you multiply the first row by negative 11, we get negative 11, positive 22, negative 22, and then negative 11. Right? If you multiply this entire row by negative 11, all the sign will change, and you're going to multiply the numbers by 11. So the new one will become 0, 24, negative 21, and 3. So 0, 24, negative 21, and 3. 0, 8, negative 7, 1. So we got this and this. So our first column is complete. We got what we wanted in the first column. And now, what do you observe? Do you observe anything here?
You get 0 out all row 3 by subtracting 3 times row 2.
Exactly. This entire row will become 0. If you add this, if you multiply this by negative 3 and add with this number. That means you're going to change row 3 now. So the new row 3, the second new row 3 is the current row 3 minus, multiply by what? What you're going to multiply the row 2 by? By 3. If you multiply this by 3 or negative 3 and combine with this, the entire third row will become 0.
Would you put the new row 2 as part of the equation, or would it just be outside? Did you change row 2?
The new row 2, not the old one. When you change something, you disregard the old ones. So we had the old one here, but once we get this matrix, there is no more this matrix. This doesn't exist anymore. So you have to treat this as a row 1, row 2, row 3.
Okay.
So if you want to do the math on the side, current row 3 is 0, 24, negative 21, 3. And when you multiply the second row by negative 3, we get 0, negative 24, positive 21, negative 3. When you combine them, the entire row becomes 0. So 0, 0, 0, 0. So we rewrite 1, negative 2, 2, 1, 0, 8, negative 7, 1. The new row 3 is the last point. So we wanted to have 0 here, we have 0 here. Oh, and also at the same time, we can make this 8 to 1 because we want to get 1 instead of 8. So we can do 2 rows at the same time, so we don't have to rewrite our matrix over and over. So let me also change row 2. How can you convert 8 into 1 in this place? What do you have to do? Multiply by 1 over 8. So the new row 2 will be 1 over 8, the current row 2. So this line will be 1 here, and then negative 7 over 8 here, and positive 1 over 8 here. So we divided 0 by 8, 0. 8 by 8, 1. Negative 7 by 8, we don't know. 1 by 8, we don't know. So we get fractional, but we have to. We have no choice. Don't convert them into decimal. Keep the fraction because you want to get the exact result, not an approximation. Okay, so now we are pretty much happy with the entire column 1 and half of column 2. Entire column 1, half of column 2. That means now we want to make this to be 0 and you'll be happy, right? So how can we make the negative 2 to be 0? So we are going to change our row 1. So what operation we should use this time? the new row 1 will be what? The current row 1, and then what you're going to do. How can you make the negative 2 into 0? Good job. Current row 1 plus twice this row 2. Let's do the math, then you'll understand. So current row 2, let me change the color. Current row 1 is 1, negative 2, 2, 1. If you multiply this row by 2, you get 0 times 2, 0. 1 times 2 is 2. Negative 7, 8 times 2. What do you get? You can cancel 2 and 4, 2 and 8. You get 4. So you get negative 7/4. And then the last one, you have 1, 8, and you're multiplying by 2. So 2 and 8 cancel out. You get 1/4. So 0 to negative 7/4, positive 1/4. And now you're going to combine them. So 1, 0 is 1. This cancel out, we get 0. Let me do the math here. We have 2 minus 7/4. This one, let me change the color. 2 minus 7/4. And then we have the last one, 1 plus 1/4. So the last two columns, we actually have to really add them. So here there are 2 ways that we can do it. 3 ways. If you don't use a calculator, then you need LCD. So take your LCD and then combine the numerator. If you want to do shortcut, you don't need the LCD. You multiply these 2 and combine the negative 7. So 4 times 2 is 8. 8 minus 7 is 1. So this should be 1/4 without using calculator. Or if you want, you can use a calculator, but you cannot use decimal. You have to use a fraction. Same thing here. You can use calculator, but you don't have to because you can do it shortcut way. 4 times 1 is 4, and then you add the 1. So 4 plus 1 is 5. It's 5/4. So this is 5/4. So we have 1/4 here and 5/4 here. So we rewrite. This is our new row 1. So we have 1, 0, 1/4, 5/4. And we have 0, 1, negative 7, 8, positive 1, 8. And the last row is entirely 0. So now we are happy. We have our first column and second column as we wanted. 1, 0, 0, 0, 1, 0. Now, is there any way you can make any of these 0 or 1 without affecting our column 1 or column 2? If you can think, no problem, you can start working back substitution. In reality, you actually cannot. Because if you want to change this, then you need the help of this line. But if you use this line, then this 1, 0 will not be 0 anymore. This number will replace your 0. And also this will not be 0 anymore. I mean, this will not be 1 anymore. It will become 0, something like that. So we cannot change any of these. We cannot make them to be reduced anymore. So we have to keep it. From here, we have to use back substitution to get x1, x2, and x3 or xyz. They have xyz here. So back substitution, starting from here. So this entire column is x, this is y, and this is z. Oops, the color is bad. One is green. This is x, this is y, and this is z. I'm using XYZ because if you observe our question, they have XYZ instead of X1, X2, X3. So whatever you have in your given equations, use that variable or those variables. So the second column, so in the second row, what information we have in the second row? What is given to us here? 1y minus 7x equals 1x. So we write the equation out. Y minus 7/8z equals 1/8. From here, we can solve for y by adding the z. So we get y equals 7/8z plus 1/8. This is our y. So y is not independent. It depends on the value of z. Now, from the first line, we get another information. So what information we get from the first line? What do we have now?
X plus 1/4 times z equals 5/4.
X plus 1/4 of z equals 5/4. So what can we solve from this equation? Which variable? X, because X is single. So we get X equals negative 1/4 z plus the 5/4. You observe both X and Y, they are dependent on z. So what is z? Any real number. So we say z is itself. Z could be anything. And then X and Y, whatever we have for Z, that will determine what X and Y is. So what type of solution we have here? Unique solution, infinite solution, or no solution? Infinite solution. Because we can replace Z with infinitely many numbers. We can from negative infinity to positive infinity, anything Z can be. So your infinite solution. So how do we write this solution then? We state we have, oops. So Z is Z. So the solution, we write infinite, but then for infinite, we have to indicate each variable. Our X is negative 1/4 of Z plus 5/4. Y is 7/8 of Z plus 1/8. And Z is anything. That's how we're supposed to write the solution.
I have a question. Okay, so you said originally the goal was to have 10000100001. That's the Gauss-Jordan elimination? So you didn't achieve that.
We could not because that format is only for unique solution. But before we start doing that, we have no idea what type of solution we have. But our goal always should be to get an unique solution.
So what was this whole process called?
Gauss-Jordan elimination.
Oh, it is called that. Okay.
So our goal is always to get a unique solution, if possible. But not every system has a unique solution. So once we try to do Gauss-Jordan elimination here, we realize it doesn't have a unique solution. So we cannot achieve the matrix 10000100001. We could not get it. It's impossible. So we stop here because there is nothing we can do anymore. So when you cannot do anymore, it means you have to go back substitution and figure out your X, Y, Z or your variables. Any question?
Put like Z, and then like that little symbol in the R to indicate Z is all real numbers.
No, we just simply use a variable for z because that z has to be in these two equations. So you cannot put 7/8 r and -1 for r. It's not possible.
No,
So
no,
you know in your mind that z could be anything.
no, not just like R, like, that's like notation. I'm trying to think of it's called. It's like,
All real numbers.
yeah, all the real numbers, like,
Mhm.
it's like.
But you cannot use it here because your z, whatever you have for z, they have to be visible in x and y. So what many books do is they replace z with, they assign z with a different variable. For example, they say z is t. That means on y is that t and x is this t. Okay, so you can assign a different variable, but you cannot assign the symbol, any symbol. And for my case, I like to see my z, my independent variable. So I keep my z and then x and y is in terms of z. But if you see in other books, they have different variable, it means the same thing. Whatever is free variable, that's independent. The other dependent variables depend on that independent variable. Any other question? Okay then, so now you know how to apply Gauss-Jordan elimination, and we don't always get what you want to get. So go ahead, try this. This is much shorter than what you did here, but make sure to show the work. Like the way I showed my operation, what operation I'm using, and which row I'm changing, you must show the details. And let me take your attendance now. Today is my turn. Brandon C. Joseph. Justin. Zibran. Shivu.
Here.
Michelle. Zach. Zach Joel. Is it Zach or Jack? J. Okay, Jack. Ashif Mahi. Darius.
Here.
Winston. Abigail. Shane. Emily. Kanar. Christine. Edison. Maisha, probably not here. She's not here, right? Brandon, Rhino, here. Alvin.
Here.
Shafal. Shafal Tamzid. Alexander. Shitila. Wenchuan. And Kailun. Kailun Yu.
Where?
Most of it.
Most of the time. So this is not a coefficient of interest, but then I
Because
realized,
we have two variables.
right, but you have two variable free rows, so that's allowed? The reason we bring it up was reading the notes to each. And it's hard to, I don't know whether she can, maybe she can, but there's a line before the last column. So she might be confused and think that this is the coefficient matrix.
No, when the column is visible, it definitely know it's not the coefficient matrix, it's the augmented matrix.
Right, but because she's blind, I worry that she might get. I'll just explain it.
Yeah. So when she takes her exam or because of homework, you can tell her that this is augmented matrix, no coefficient.
I'm sorry, when she does the homework,
Or she takes the exam, she'll take the exam with zero.
I'm not sure. Oh,
So usually most of the time we use augmented matrix, not the coefficient matrix.
oh, okay,
The
okay.
coefficient matrix itself is not that helpful to reduce.
Um,
We reduce the augmented matrix because of the last column. We have to see what numbers we get in the last column,
Right.
and that's the solution.
Right.
Yes.
okay,
You don't have to work alone, you can talk to your neighbors, guys. You can share your ideas. You can make noises. It doesn't have to be so silent here. Did you ever visit any graveyard?
Yeah.
Did you see how silent the graveyard is?
No.
No? Was it noisy?
Yes.
Did you see many people there?
Yes.
Probably that's why.
so. Weird. You want that?
And
We want to have good. We want to. That doesn't mean we are going to. We just want to.
Yeah.
So we have one bracket and we are changing row 3. So row 3 minus 8 times row 1. Why is 8 times row 1? If you want to change the current to 0, no, go column wise. First, you want to have this is 0 and this is also 0. This is what you want. So multiplying by 8. Yes, you can get it, but your goal should be this one. You want to get negative 5 to be 0. So you're multiplying by 5 here. If you're done, I have one more. One more. So if you don't want negative, you want 1 here, what can you do? We can think of it as divided by negative 2. we currently current routine and which row introduce to get rid of that negative two, row one or row two. If you use row one, then use the one, the zero will not be zero anymore. The number.
But-
You want to use something that has zero on the first place because we want to keep that zero on the pattern. So instead of using row one, which other way can use row two. So what's up next? And now you're going to change the three. If you're using the one, you'll problem with zero times one. Instead of using row one, which other way you use? So, so what is the solution? And next one. Two. And that. Okay, good approach. Then. So your first, when you have zero one, this is row one or row two?
Row two, this is just, I was just writing.
Right, okay. You're doing well. Yes. Almost correct. I mean, you're not done yet. So far it's correct. But this number doesn't look good. And how I do. Which one you're doing? The first one or the second one? So your goal is to make 2 into 0 and then 5 into 0. Start with that. Why you're changing row 1? Is it row 1 or row 2? Or row 2?
Minus 12.
Good.
Oh, that didn't do it.
Why not?
I don't know. It's just-
Be confident.
Really look.
Okay. But I think this number is wrong. So check your work again. The idea is okay, just need to check in that. We done this one. So let's go down this one. Which you can get help from the first row or the second row? If I would have multiplied the second row, right? The first one is all over. So then you get the first one. So maybe have the first row. So partially multiply the first row by so that the third row will become 0. Depends. If you're multiplying the negative number of every element in that row will change. But if you're multiplying by a positive number, then one will change. Whatever we are changing, leave that row alone and multiply the other rows by one. So instead of dividing this by 2, multiply this by -2. Then if you divide this by 2, eventually the fraction for F25. Plus later, there will be one situation where we're not allowed to multiply or divide whatever we are changing. So that's like whatever you're changing, you leave that alone and multiply or divide other one. How are you doing? Really done the first one? How did you come up with this? Who's going to be it looks lighter. Only it's lighter than mine. Mine is too power. Because I'm looking for something relevant. Or is it a full edition or opposite edition? Professional or the master? So something with professional edition, not university. I'm already we have no solution, perfect. How about the second one? But you did well. Now your goal is to make this one. So is this one or you want one? So you have one from the power. Now what can you do this 92? So what this becomes? So you have 0, 0 numbers. What does that mean? no variable equals something other than me. Perfect. No. How are you?
So I think I was okay so far. Still right? Then I felt stuck. Then I don't know where you could just. So the road to is minus 150 over to that gives you 0, 1, minus 1. That's here. Then you got 0, 2, 19. You just multiply through by 0.
You cannot multiply this. It's multiplied by non-zero number. So we can get the help from this row to make this 0. Yes, so we can make this 0. Can you make 2 into 2? How can you turn 2 into 0?
Multiply this by -2 and then add.
Proud.
Okay, but could I just cancel it?
Yes, you can, because we have the same zeros. You can only make the last one 0, not the final one. They use two-sided arrows. And you don't switch columns. You are to do it. Somebody can hear? But we can't figure it. We got it. You don't want one to be here, you want at the end, the one to be here. You see the process, if you don't have the one here, no problem. What would I see at the end? Do you have one at the position?
So it doesn't matter during the process.
You see that you have 95, you can easily make 95 into 1 by doing what? Okay. Who else need help? And now this is something we have no variables equals 21. Does it make sense?
No.
So what are the solutions?
Impossible solution.
Great. So now you're going to make this 1 and this 0. Let's say if I can make 5 into 1. So you write row 2 is row 2 divided by 5. And then how can you make this negative 2 into 0? Or you can do the same, you can change both of them at the same time. Multiply this by 2 and this by 5, add them. Or you can do it in one step. Do it one step by step. How are you doing? You're not following the economics. Yeah, you are close. So you can switch them around and we have one here and four you switch them. And the goal is to, since we have three variables, that means we want your last interval to be 0. The solution set. Here's my no, x is 0. If you've done it the second one, this is the solution 0, 3, half, and 1. If you don't have 0, 3, half, and 1, check your work. You should always, it will be helpful if you write down what is a goal. So from here, your goal is to get a matrix similar to this. Your goal 1, 0, 0, 0, 1, 0, 0, 0, 1, and so we can do. But we have 4 rows. That means we want the last row to be all zeros. These are goals.
Oh, so I start with the last row. Okay.
No, you start with the first column. We have 1, but you have negative 1, that means we have to multiply this one.
Oh.
Then we have 0, you want 0, but you have negative 2, so you can get the help from negative 1. The 3 here becomes 0 in the first column, so first row. Multiply this by 3, get. You have negative 3, multiply this by negative 2, and then add to the 0.
I
You
don't
can
think we're
change.
starting yet.
No problem, it takes time.
Yeah, that's a lot of work.
Last time the exam, when you only one of these, and I'll try to give you something smaller to work with. I'll give you 2 more minutes, okay, and then you're going to solve them together. Perfect. Now read what information is that. The last information says no variable is 19, doesn't make sense. So what type of solution is that? No solution. We call that inconsistent. Okay, so let's do them together. For the first one, our goal is to get the resulting matrix 100100 on the left side. And for the solution, we want a number for x, number for y, but we want the last digit to be 0. If we have that, then we have a unique solution. And we always desire to have a unique solution. So this is our desire to get. But just because we have the desire to get something, it doesn't mean we get that in our life, right? Our life is not fair. So we want to see, can we get that? So we need to change everything. We have 1 here, and we desire 1, so we are fine. Now we have 2 here, but we don't want 2, so we are going to change our row 2. We want to get 0 here, so we keep our row 2, and we are going to get the help from row 1. What do you need to multiply the row 1 by 2 get to make 2 into 0? Negative 2. And then we want negative 5 to turn into 0. So that means we are going to change row 3 also. So we keep our row 3 and we use the help of row 1. So what do we need to multiply row 1 by this time? 5. So we're going to add 5 times row 1. And then you can do the math visibly. So current row 2 is 2, 1, 1. Multiply row 1 by negative 2 will give us negative 2, 4, negative 6. When you add, you get 0, 5, negative 5. So this is our new row 2, 0, 5, negative 5. We are also changing row 3. Current row 3 is negative 5, 8, 4. When you multiply row 1 by 5, we get 5, negative 10, and 15. So when you combine, we get 0, negative 2, and 19. This is our new row 3. So we changed row 2, we changed row 3, but we do not need to change row 1, so we leave our row 1 alone. Now we want the 5 on the second row to be 1. So we make a wise decision. We divide, so the new row 2 is the current row 2 by 5, or 1/5 of the current row 2. Let's do that first, and then we are going to change row 3. So 1, negative 2, 3. The new row 2 is 0, 1, negative 1. We did not change row 3, so 0, negative 2, 19. So we change this 5 into 1. And now our goal is to change this negative 2 into 0. So we are going to change row 3. So the new row 3, since we want to have 0 there, so we keep our row 3. And which row we get the help from? The first row or the second row? Row 2. You cannot get the help from row 1 because then the 0 on the first position will not be 0 anymore. So we definitely need the help from row 2. So we add 2 times row 2. So our current row 3 is 0, negative 2, 19. If you multiply row 2 by multiply by 2, we get 0, 2, negative 2. So you get 0, 0, 17. Sorry, this is 19, yeah, 17. So 0, 0, 17. We have 0, 1, negative 1, 0, negative 2, 3. Even though we desire to change this one, but we don't have to because we already got the hints here. the last row is telling us no variable is 17. What does that mean? How can no variable be 17? Like, does it even make sense? It doesn't. Since it doesn't make sense, that means we have no solution. Okay, so we desired to have 0, 0, 0 on the last row, but it could not because it doesn't have any solution. So we can stop there. Any question? Okay, the next one. It's a little bit longer, but our goal is to, since we have 3 variables, so we want to get 1, 0, 0, 0, 1, 0, 0, 0, 1. 1 for each variable. This is what we want. But we have 4 rows. So what do we want our row, the last row to be? What do you want? All zeros. 0, 0, 0, 0. So for X, Y, and Z, we want them to be some number, but we definitely want the last number to be 0. If the last number is not 0, we will end up getting the same thing as the last one. No solution. So this is our desire. But just because we have the desire, it doesn't mean we will get that. We are going to work to see if it's possible or not. If it's possible, then we have unique solution. X is that number. Y is that number. Z is that number. And the last row entire 0, it doesn't tell us anything. We just disregard the last information. So, -1, 2, -1, 2, -2, 2, 1, 4, 3, 2, 2, 5, -3, 8, 5, 17. This is what we currently have. Unfortunately, we have to change all 4 elements on the first column. So we can change all of them together at the same time. The new row 1, we don't want -1, we want +1. So what do you have to do? Multiply by -1. So it's -1, row 1. Then -2 on the second position, we want that to be 0. So the new row 2 is the current row 2 minus 2 times row 1. If you multiply this by -2, it will turn into +2. +2 and -2 will give you 0. The row 3, new row 3, will be the current row 3. And since our row 1 is already minus, we can simply multiply by +3, and we add these two, we get 0. So this is plus 3 row 1.
Couldn't you add row 3 and 4?
We could do that also. For row 4, we can simply add these two. Row 4 is current row 4 plus the row 3. If you add these two, we get 0. Now, do you guys have these operations if you're done? Do you have these operations? Do you? I just want the next matrix without doing any math. That's my goal. So if you do have, you don't have it, right? The same operations I have? No? Kind of. So can you also tell me the new page break? The new matrix after doing all these modifications? The first one will be 1, 0, 0, 0. How about the rest? What do you have?
First row, I have 1, -2, 1, -2.
And then?
And 0, -2, 3, 0.
Mhm.
0, 10, 7, 22.
7, 22,
0, 2, 8, 11.
2, 8, 11. Thank you. That makes my life much easier. So that means now our goal is to change all of this. The -2, we want to have 1 there. So the new row 2, how can you turn -2 into 1? Dividing by -2. So new row 2 is current row 2 by -2 or multiply by -1/2. Then the 10 we want to be 0. So we can multiply row 2 by 5 and then add. So row 3, the new one is current row 3 plus 5 times row 2. If you multiply this by 5, we get -10. Add with the 10, turn it to 0. And we also want this 2 to be 0. If you want this 2 to be 0, it's easy. Just add these two numbers, you get 0. So current row 4 is, so new row 4 is current row 4 plus row 2. And then you get the next column. I hope you do 1 0 0 0 1 0 0. What number we have here? We didn't change row 1, so we're supposed to have the same number. -2. And do you have the last two columns?
It's more random.
You did differently, but you get the idea, right? So figure out what numbers you have here, and then and then you're going to change these two row again, and then at the end, it does have a unique solution, and the solution you're supposed to get is x equals 0, y equals 3/2, and z equals 1. Okay, so do the row operation. You can change everything on the same matrix like that I did. You can change the entire column. It will make you